Hello everyone. This is another webinar by Mitsubishi Electric, and again we are in a little bit different setup. So we are using some sunlight of a beautiful weather that we see here, and today we are going to talk about a topic that we have touched in many other conversations, and this only shows how important it is. And we are talking about the need of maintenance in manufacturing, particularly all the modern solutions related to predictive maintenance. So I decided that there is a high time to have a full conversation on that topic, focusing on that very important part of manufacturing operations. So today, Oliver Giertz is joining me. He was a guest before, but today we will have a very dedicated webinar on his expertise, let's say. Hello, Oliver.
Hello, Piotr. Thank you for joining this important topic to discuss all the points which you mentioned already today.
I think we can start, and I think we should be outlining the problem first. The problem that manufacturers face on that field. And according to the International Society of Automation, between 5 to 20% of the production available time is lost due to the breakdowns. So if we take this maximum number, 20%, it sounds like there is so much space for improvement in the factories, which seems it's not fully tapped today. So I think that this is a perfect example how maintenance strategies are very important for manufacturing, right?
Yeah, Piotr, that's right. There are around, you can say, 15 hours weekly where the plants loses their production due to the downtime. And you can say it's around 20,000 interruptions every year. They are having the problem that the production stop, and for sure that means a lot of money which will be lost.
And I think that the problem is even a little bit bigger, because obviously it doesn't affect only the manufacturing process itself, but breakdowns can also affect supply chains. And definitely there is a huge challenge for supply chain managers to maintain an efficient chain in the light of all of these breakdowns. So today we are going to talk how the devices itself can actually support both supply chain management and manufacturing management. Particularly, our discussion will be revolving around robots and servo systems, which can support the products itself, can support those processes, right?
That's right. But there's also a key benefit for these products, because the strategy needs to be changed in the plants, in the production facilities. So now there is a lot of, I would say, reactive actions when something happened, when a breakdown happened. But then the strategy needs to be changed to more proactive, that the manufacturers of the inside the production can have a proactive approach about using especially the solutions we can also offer from Mitsubishi Electric.
So maybe let's explore those different strategies, because I think that there is still a lot of reactive maintenance being done in factories. Can you explain those different strategies as a basis for our discussion?
So there are fundamentally, I would say, 3 different approaches in regards of maintenance. The first one is I would say, reactive maintenance. So you can easily compare it with a car. You drive your car until it breaks on the highway, and then you make the action, you repair it. But this is for sure a problem that you stop suddenly. without it's planned. So you want to drive from A to B and it stops off the halfway. So you cannot reach B in an easy way. And this is the same if you transfer to the production. Suddenly the machine stopped due to the unexpected breakdown, and then you make the action to maintain the parts which occurred this.
Just like with the car, it is not the most efficient way for manufacturers, right?
For sure not. It normally generates a lot of costs at this point when this breakdown happened. So there is I would say, second approach. This is the preventive maintenance. Makes a comparison again with the car. So you are driving your car and you are having like 10,000 kilometers, you change your oil. Every 10,000 kilometers you change your oil. So this is the maintenance based on the usage, on the kilometer you're driving, or if you compare to the production again, on the time it's working. For sure, it's giving you some advantage that you have the parts exchanged, but it's maybe not the best solution about the maintenance. But it's already for sure better than the reactive maintenance.
However, I think it's the most common on the market, right? So I think this approach to preventing problems and replacing parts at some fixed point in time, I think this is the strategy that is used the most often. However, obviously, with all of the intelligence available in today's technology, we can get better. And I guess this brings us to predictive maintenance, right?
Yes, for sure. The predictive maintenance is somehow, I would say, is the best solution in this case. It's for sure checking coming back to the car, how many kilometers it's used, how many kilometers it's driven. But it also looks how these kilometers were driven. So easy example, you have two drivers driving the car 10,000 kilometers. One is always using the motorway with a constant speed, and the other one is using the car only in the city center where there's a lot of traffic. He needs to break down the car, accelerate a lot of times. So although both are driving 10,000 kilometers, the parts which needs to be replaced at the time is different. If you're driving in the city center, brake a lot, maybe the brakes needs to be exchanged, maintenance, less than 10,000 kilometers. But on the car, on the motorway, maybe it can take longer. So this is the idea of the predictive maintenance. So it's looking not only about the distance to go in this example again, but it also analyzed how the car is driven. And this is for sure one point where we transfer this predictive maintenance to our Mitsubishi equipment, like to our servos, to our robots. So analyzing how the products are used and not only looking to the time, I would say, how long the robot was moving.
Analyzing how the machine is being used is probably another type of a challenge, and I think we will be discussing this in detail. But before we go into that details, maybe we should also mention about the financial implications. So how do those different maintenance strategies translate into costs?
Yeah, for sure. The main point for the big loss is maybe not the equipment itself. It's more or less the production stop. So if you have the reactive maintenance again, and then suddenly the production stops, that could have a big impact because you cannot finish the production. It maybe goes then further that you cannot deliver on time, maybe due to the production is stopped for hours or for days. And also then you have the spare parts probably you need. You need to make express deliveries. You need to get the people maybe over the weekend the maintenance people over the weekend to fix this problem. So there are a lot of costs which are, as I said, not the part itself, what is around this and generating due to the broken parts. I think this is the main topic. And the predictive maintenance is giving you the advantage. It plans you the maintenance, the schedule, and then you can do it in a controlled way, I would say, the exchange of the products.
Right. Yes. So the more stoppages of production that you can reduce, the more money you will save. And I think that's how predictive maintenance might change how we look at costs in factories. All right. So let's maybe discuss how do you actually get those insights from. And as I said, getting this kind of information, how machine is behaving and what it means from the perspective of maintenance is a huge and complex topic. But I believe we can go to the actual component level. So trying to understand how specific components in the machine behave. So I think this is where those predictive maintenance technologies in servo systems or in robots are important, right?
Yeah. So we as Mitsubishi Electric have developed predictive maintenance functions which are AI-based, and we have integrated them in our robot controller and into our servo system. And the big advantage is we don't need any external equipment for these functions. We don't need to have external sensors. We don't need to have a powerful PC to analyze this. It's integrated in the equipment, which for sure gives the customers the big advantage that they can directly also, I would say, using it in already existing systems.
It saves time and effort on the data analytics part, right? So the analysis of data happens in the component itself, so you're not investing in bigger infrastructure. So maybe let's discuss specific details. And I think these days robotic applications are a very good example where maintenance is very important, because the robot arms itself are quite expensive, and a lot of production is based on them. So maybe let's discuss specific features in robots that can support this kind of maintenance strategy that we discussed.
So we have for our robots a card, which is an optional card, which is called Malfa Smart Plus. So if you insert the card in the robot controller, the predictive maintenance AI functions are enabled. And this card is really on a price level which is maybe around 500, below 500 euro. And if you think what you invest to get this predictive maintenance compared to what you can lose if the production will stop, I think that's no discussion to get this inside the robot controller.
Because it is also type of a plug and play solution, right? So again, no investment necessary in, let's say, deploying such project. So the robot is equipped with intelligence by using this Malfa Smart Plus card. And what exactly does it mean?
So the Malfa Smart Plus card, as I said, is enabling the AI function, and it analyzes the robot movement. So not only looking how many hours the motor was moving, how many hours the gears, the belt were moving, it's also analyzing how they were moved, which axes have maybe small effective load, some have more effective load, and all these parameters are checked, analyzed inside the robot controller, and then giving you some information which is the level of the wear of the different parts, and then for sure give you also the idea what you have to change, what part has to be or has to get maintenance, and also it shows you somehow when, so in advance, when it would be able to or could be a break. And I think this is the function which is, as I said, like a machine learning process with some AI algorithm in the robot controller.
Right. So the AI that you equip the robot with is essentially creating a model of operation of that specific robot. So it creates kind of like an understanding of how this robot behaves in the factory, right?
So yes, it's making like a normal operation, and then it's analyzing like the vibration. If the vibration, for example, is changing, it can detect, okay, this could be a motor has a problem, a bearing, maybe it's getting old and needs to be exchanged, or the belt is getting loose. And this is something which I would say a human which is looking at the robot will not recognize. He cannot see it. And that's the reason why this sensors which we are using our own motors to analyze all these data. So this is, I would say, the big advantage. We are using our own servo motors in our robots, have the complete technology there, the complete know-how, and can use these motors to analyze the vibration changes, I would say, and they are sometimes slightly only change, but the system can recognize it and analyze it and give you the information that something is not okay or will be in the future not okay.
In that case, maybe we should also discuss servo system itself. I mean, general servo systems, because for me it sounds like the actual motion control is even more complex than that, because the robot itself is a known mechanic, right? Yes. It is a robot arm that always looks like this, and you can analyze specific characteristics of movements and so on quite easily. But when you install the servo system, so the mechanics is always different. Therefore, recognizing this kind of problems with the motion system, for me, sounds like much more complex task. So how does it look like with the motion control?
Yeah, Piotr, for sure, you're right. The robot is somehow, I want to say, a closed system, and the controller motors know what kind of mechanics are connected. Looking to the servo system, we are also, as I said, having the AI function predictive maintenance integrated, but we can also detect different kinds of mechanical parts which are connected to the motor, and it can be also analyzed. So, example, you have a ball screw connected to the motor. You move the, I would say, system in the normal optimal way, and then it's learning by the current, by the vibration, what is the optimal status. And then if, for example, over time, the ball screw is getting dry, it needs lubrication, it means the vibration of the mechanical vibration changed slightly. And this can be detected by the servo system that something changed compared to the optimal movements. But we can not only use this ball screw as an example, we can define different mechanical parts. So you set a parameter, so I have connected a ball screw, or I have connected a gear, a mechanical gear, and it can then detect also the wear of the gear. Other possibility is if you have a linear track with a belt. If the belt get loose, it also changes the vibration, mechanical vibration. And this is what the system can recognize and give you then the idea about the maintenance, changing the belt, looking to the gear, it's getting old. And as I said with the ball screw example, that it needs lubrication.
Right, and I think it's essential to note that this predictive maintenance in servo system is not relevant only to the servo component itself, but to the, let's say, bigger parts of the machine. So it gives you insights into how the actual mechanical parts in the machine are working. So I think it's very important to note that. But those functionalities that you described, they are part of the functionality of the servo drive, right?
Yes, these functions are integrated in our actual Mel Servo MRJ5 series as a standard. So you don't need to pay anything for it. It's integrated. You have to activate it. As I said, then it's learning the optimum, and then you run it in your machine, and then it will give you some warnings, some alarms, which you for sure can also then show on a higher level SCADA system or on a HMI, for example.
And maybe we should talk about this a little bit because considering the amount of servo drives that are available usually in different parts of machines, in different parts of production line, it seems like monitoring all of this information might be a little bit challenging, because let's say you have a machine that uses 100 servo drives. You can't really check every single point of data in such a system. So how do you approach monitoring of those bigger servo systems in that case?
So we have created a dashboard which is based on our Genesis software, which gives you an overview, for example, of the production plant. There you can see different products which can be monitored, especially also our robots. And there you can easily see in a quite good overview, in a visual overview, which robot, for example, needs which maintenance, which is the level of, as I said, like the wear of the robot. But also you can get additional information, how many hours it's running, or also like information, asset information, what's the serial number, what's the version number. And this is a software which is based on the web browser, for example. And you don't need to be a specialist to understand everything. It's quite easy to understand. It's quite easy to visualize. And for sure, there's also possibility to show other products from Mitsubishi in this way as an overview about the status of your facility, of your plant, or production plant.
This visualization point, I think it's very important for general asset management, not only from the predictive maintenance point of view, because like having the overview of how your system works and understanding the behavior of specific components, but also how they work together, is extremely important. So obviously, pretty much every single system that does predictive maintenance will be also supplied with a proper visualization of those assets, right? So that's clear. And maybe let's talk about specific benefits for manufacturing companies that this kind of approach delivers. So summing everything up that we discussed so far, you have intelligent components that give you a lot of insights. It's not data points, those are actual insights that are then visualized in a more comprehensive asset management system. And then this kind of setup is put into the factory. So how does the average manufacturing company benefit from that?
So I think the one big advantage is that they can schedule the maintenance. So it means they can organize in a advanced way when the maintenance will happen. So probably there is a general production stop due to maintenance, and then they get with the solutions, with the dashboard in advance when the maintenance of the robot should happen. And then, as I said, they can schedule it, they can get the parts which they need to exchange in advance, no hurry up, no express delivery, which is more or less then giving the advantage of the costs. So it will be planned. Everything will be in a cost-effective way, and to minimize the cost. I think that's a big advantage for the factories, that they have planned time, planned cost, not sudden cost happen due to emergency, what we discussed in the beginning, no additional cost due to the unexpected breakdown.
Right. And as you said before, so the one thing is the cost of replacing parts, but of course the major issue that most manufacturers face is the cost of stop production, which of course always costs the most money in every facility. But as we discussed, this also has implications on the supply chains, right? So with this new approach, with this special insights you get from components, how this affects supply chains?
So for sure, if you have a stable and effective production operation, so you can secure the supply chain, so you can deliver the parts to your customers on time. You will not get probably penalties, because it's often happen. If you are too late, you have to pay penalties. But if you can have a stable production, stable operation, you can secure it. The reliable delivery supply chain.
Some of it probably can be also automated a little bit, right? So if the robot notifies about a problem with its parts, I can imagine that this advanced supply management system can actually act on this information from the robot. So very advanced automation of part orders and so on is not a feature anymore. It is quite common. Good. So maybe let's discuss on the real life examples. So I think that in your line of work, you work a lot with actual manufacturing companies. So maybe you can share some of examples from your expertise.
So there is one good example we have in Germany. That's Mitsubishi high-tech paper. So they have implemented a monitoring system for the fans which they are having in their production. And this investment about the monitoring system for the predictive and the predictive maintenance is already paid off in only 1 hour, because they are producing 300,000 kilogram paper per day. And if this production would stop for 1 hour, it costs so much money for the company that the investment is really in only 1 hour paid off. And this is for sure only one example. I think you find a lot of other examples on the market where you see that the investment for such kind of maintenance function is quite low compared to the loss you will have.
Well, when you say quite low, I think it doesn't cover it. So you said, let me just rephrase this. The cost of creating a predictive maintenance system was equal to 1 hour of stopped production.
Yes.
So this is, I think, quite amazing difference, because the return on investment is crazy.
That's right.
Right.
That's right.
So, and I think that this is due to the approach, where this is what we discussed before, that you don't need to create an infrastructure for data analytics. the data analytics happens in the component itself. That's the huge difference from the perspective of cost of implementation, right? Good. I think that that gives us an idea how all of this works, and I think that the main point that we should remember from our conversation is that a lot of magic can happen in the component itself, right? So obviously, the best way to understand a product is to be very close to it. This is the difference comparing with big advanced analytical platforms, which have great ability, but to be able to actually analyze the same amount of information from the component is much harder and much more time consuming. In case of robot, you are getting this kind of, or servo system, you are getting the same insights basically by plug and play approach. So I think that is one of the main points that we should keep in mind. Anything else you would like to leave our audience with at the end?
Yeah, I think the main point is that the strategy needs to implement it for the predictive maintenance in the factory. So there is a change of thinking. So they need to switch from the maybe reactive actions to the proactive thinking about using the predictive maintenance. So it's a change. They have to think about it. So it's maybe to start in the beginning with a small part only to implement this predictive maintenance, which is maybe a critical part in the production, and then scale it up to the complete production. That could be like an advice to or from us to the audience.
I think that change of mindset is important, and I think it's enabled by all of these technological possibilities. So I think it's important to stay up to date with this kind of knowledge about what's new in this kind of technology, so that you know better what kind of strategy you can implement in a factory. And that's one of the reasons why we have these seminars. Thank you very much, Oliver. It was a pleasure. And I think we will discuss some more things together.
Yeah, thank you, Piotr, for these discussions today. And for sure, we will continue about discussing about new topics, upcoming topics. Thank you.
Thank you very much.